Welcome back to Arcade. I am Super Tommy, and in this series, we are creating a Sokoban or push box puzzle game. In the last part, we left off with making sure our boxes cannot be pushed into other boxes or through walls. So as you can see, we have that working. It looks good. We can't push them past the level bounds, and we can track each individual box when it covers over the correct color. So in fact, let's go down here. We should, if we push this blue, which I think blue is 51, which says 1, so it's got 1 target covered, and to the right it will have 0 targets covered because it's covering red. So what we're going to do is now create a check so that we know when all the colors are properly covered by the correct box. So we're going to do that by knowing how many targets covered by color versus how many boxes by color there are. Basically, they should match. So let's go down here and we're going to write this method. It doesn't have to be in the scene. We'll leave it in here for now. All right, private. Let's call this all targets covered. So we have boxes by color and then targets by color. So let's see, so box, let's get target colors. Target colors, it's going to be the keys of targets covered by color. So those are all the target colors. And we need to make sure the count is equal to the count of boxes. So let's see, let's go for a loop. We're gonna loop through all the boxes, rather all the target colors. Length, and then so we're going to call this target color. It's target colors I. Now we're going to want the box color. If you remember in the previous part, we have to convert from target color to box color, or maybe we did the other direction. Color utils, box color to target color. So we will need the inverse of this, target color to box color. Now we're going to get a target color, which is a tile index, and then we're going to switch target color and color.target orange, which will give us box orange, color.target red, which will give us box red, target blue, which will give us box blue, color.target green, which will give us box green. Okay, color.target gray will give us box gray. We're going in default. What do we do for default here? Default will just be orange. We'll go with that. And target color to box color. Okay. So get that. Let's go back to game. And here we're going to import this target color to box color. Okay, so now we have that conversion, or that way to convert. So target color to box color. Target color. Okay, so now we have the box color for the corresponding target color. This is straight. We want a number. Okay. Okey doke. Now we have the box color, we have the target color. So what we want to do is get num boxes, let's say. So then we have this dot boxes by color, box color. So that is length because it's an array. So that's num boxes. But realistically, just for safety, if box color in this dot boxes by color, if for some reason it's not there, then we're just going to continue. We're not going to do anything. So okay, now we have num boxes. So we want the number of boxes to equal the number of targets covered for that color. And so what we want to do, so this is going to return true or false. So if, let's see, this, so we'll have num covered. So this dot targets covered by color, and we have target color. So this gives us a number. So if num colors, num covered, is less than num boxes, so if there's less covered colors, or there's more boxes than there are covered colors, then we have not covered all targets. We're going to return false immediately. We're going to check the rest of the colors as long as any of the colors are not. And then if everything is covered, at the end we return true. We've had checked everything. So let's do this. We'll do this check after we push a box. So that is in our tween move method. So here, let's see. And here. So let's here, we're gonna, instead of logging that out, we're gonna log all targets covered. Let's see. I'm gonna push this gray box. Well, that is incorrect because clearly all targets are not covered. So let's see what our code is actually doing. All targets covered. Let's push. All right. So let's step through this. So target colors, for loop, target color, box color. Box color 9. I'm going to move myself here so you can better see. Okay. So box color, target color, num boxes, num covered. So num boxes is 1, num covered is 1. True for box color 9. 9 is green. That is accurate. Let's keep going. Third color, box color. Okay, let's see. Box color 10. Box gray. That happens to also be correct. We're just gonna put this breakpoint over here and just continue. Oh. Yes. So, right. Okay. There's a couple of ways to handle. So the problem here is actually that our, right here, where's it? Our boxes by color is only filled, no, sorry, our targets covered by color is only filled when we cover a target by that color. So the number of keys is only going to be gray and green in this case, or the first time we push gray, only gray. So we will just initialize targets covered by color when we do the boxes. So let's see, extract boxes. And so these are all the colors. Then we get that. We can also do right here, when we go through each of the colors, we're gonna targets covered by color, and we're gonna have this is target color, and box color to target color, our box color. Then we are going to initialize our target color to count the targets covered by color count to 0 for each color. Now let's see. Let's go back to our console. And this should say false. Good. Should say false right here. And there's 2. And this should say false. 3. This should still be false. And then right here, this should be true. And there it is. So there we have the boxes properly accounting for when they're all been covered. So let's bring that. Then again, this is false. We've moved it out. Yes. And if we push these back, we should once again be true. There we go. So that was not too hard. We may want to clean up some of this code. This scene is, of course, getting fairly large. Well, not too bad, 377. But so we'll think about that. For right now, let's actually make a real Sokoban level, or at least realer. So Sokoban Online, we're just going to copy their first level and play. Let's see, lessons. So lesson 1.1. So we're going to reconstruct this basically in our grids. Let's see, there are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 tall. I think we're also 8 tall. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And they're 8 wide. So that is perfect. So let's see, let's just copy their level. So obviously we have 2 blanks to start here. And then we have a wall tile, wall tile, wall tile. And then we have blank, and blank, and blank, blank, blank. And then right below it is a wall tile, blank. Then we have 3 blanks going down. And we have another wall tile here. And this is going to be nothing. Right, so we have here another wall tile. Obviously, you see this is not the easiest way to make a level. It would be easier if we were using something like tiled, which we will cover in a future part here. But it's good to understand how tiled actually works, since none of it is magic. Key, nothing here is magic. This is my thing is wrong. None of this is magic. These are all made by humans, like you and me. And let's see, so we're just gonna do this by hand to get a full understanding of what is happening. So title basically just generates data just like this. And then we use it to make our game that way. This is way harder to read, of course. So let's see. And in fact, if you wanted to make your own simple level editor, which I don't necessarily recommend, but you could, since tiled is free after all, it's probably not necessary. 1, 2, 3, 1, 2, 3. So 1, 2, 3, 4. 1, 2, 3, 4. So I guess we are more than 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we're more than 8 wide. That's okay. We'll just Get rid of these. I'll probably make this in an Excel spreadsheet as well, which might be easier. And then simply load a CSV. That is an option. So let's see, 1, 2, 3, 4, and then this is going to be another wall. This is going to be another wall, and this is going to be another wall. Okay, let's see what we got. Let's see if it even breaks. It might. If we didn't account for, okay, that's good. If we didn't account for having no player or no boxes, but I think we did. Here's the level. It looks about right. Let's just compare. Okay, that looks pretty good. Now we're going to put our player, which is 52, index 52, and the player starts right there, which I believe is over here. So 52. Let's see. Should be right there. That's our player. And then let's just pick a color box. Let's go with, what's a good box color? Box color. Let's go green. How about that? Green. So 9. So we want one right below. That's 9 box. One over here. Green box. One over here. And then one right here. Look at that. So now we're going to put the green targets down at each of these end of the halls in the level. So green 64. So we're going to put one here, 64, one here, one here, and one here. Let's see. That looks like the right level. Let's try it out. And true. There we go. All right, so we've set up a level based on Sokoban lesson 1.1 over here. Let's close this out for now. We got a real level and we check that all the targets are covered by all the boxes. Now the next thing we're going to do in the next part is track the number of moves. So the point of Sokoban is to do it in the least number of moves. I'm going to track the number of moves it took to complete. And then once we hit true here, that all the targets covered, we're going to show a game over screen.